Hello everybody! In this video we're going to see yet another example of how we can compute an expected length using MATLAB. And the setup for this problem is we're going to imagine I have a length 10 vector where I'm picking kind of for elements of my vector random integers between 1 and 30. And what I want to do is if I see an integer that appears a second time, so anything other than it appearing once, I'm going to remove it for the vector. And then my question becomes, well, how long do I expect this vector to be? So remember, it starts out as a length 10 vector, and let's say I have something like 1, 2, 3, 3. What I'll end up with, so that's the vector, so 1 appears once, that's fine, then I have 2, then I have 3, but 3 appears again, so I'm just going to leave it here. So here's an example where I just started with 4 elements and it got cut down to 3 elements. You can imagine the same situation where I start with 10 elements and then kind of remove the duplicates. So let's see how we can model this. I'm going to create a new function, and let's call it delete underscore dupes for duplicates. And let's see, I'm not going to have any input, but what I want it to output is how many duplicates, or kind of how many distinct numbers appeared, I guess I should say. So because this is a little bit more complicated of a function, what I'm going to do is first I'm going to write the function that kind of counts how many distinct elements appear. And you can imagine if I'm counting distinct elements, like let's say I have a vector so it's length 10 and it's just 1, 1, 1, 1, 1, 10 times. What ends up happening is I say, okay, 1 is the only distinct element, so I'm just going to count it once. So our vector gets cut down to length 1. So that's how we're going to end up coding it. But let's start by saying, okay, we're going to create our vector v equals rand I. So remember, the original problem is I want to pick random integers between 1 and 30. And then I want to create a row vector with 10 elements with these random integers. So there's v. And now let's say for I equal to 1 to 30. So what we're doing here is I'm going to see how many of these numbers 1 through 30 appear in the vector v. So I'm going to say, does 1 appear in v, does 2 appear in v, and so on. So I'm going to say if any element of v is equal to I, then I want to increase the count of a dummy variable. So t is going to be our total. So let's say t starts at 0. So we're assuming that no value appears. Of course, we will have some value because it's a non-empty vector, but let's start at 0. So if any v is equal to I, then what we're going to do is we're going to say, well, t is equal to t plus 1. Then we're going to end. So, okay, this was just the delete dupes function. We're going to write the function that does the calculation for expected length in just a moment, but let's save it and run it a couple times. So let's say I run delete dupes, and we can see here, okay, I got 8 distinct numbers. I ran it again, 7 distinct numbers. So remember, this is a vector that starts out with 10 elements. So I can have at most 10 distinct elements. There's 9, 8, 8, 9, 6. There's 10. I wanted to see, could we get it with exactly 10 distinct elements? All right, so now let's actually compute the expected length. So basically, if I'm removing the duplicate elements, how long do I expect the vector to be in the end? So I'm going to create a new function. As output, I'm going to return e for the expected value. And I'm going to call this function find ev for find expected value. Now I am going to have an input. What this input is like usual, n is our total number of experiments. And I'm going to start by saying, okay, for I equal to 1 to n, t, so this is going to be our total, remember, so we're going to assume we start with 0. This is going to be equal to t plus what happens if we run delete duplicates. Then I'm going to say end. And again, expected value, this is going to be e is equal to the total over how many experiments. right, so find EV, let's save it. And now let's run it a couple of times. So let's do find EV, and now I need to specify the number of experiments. So we're going to use the same principles as usual. The more number of experiments I have, the better the probability estimate. One thing I wanted to say that I forgot to mention when we were actually coding back here in the delete dupes. So if you can think of like a more elegant or efficient way of coding this, feel free to. I just did it in kind of a very straightforward way, but this is by no means the only way. So now let's run find EV, and you're going to see why did I bring up that point about efficiency. It's, well, if we write better code for delete dupes, we'll be able to kind of run our find EV function with even bigger numbers, and it won't take MATLAB as long. But let's start with 5, and we can see here, okay, 8.6, so, you know, we start with 10 elements, we expect 8.6. Now let's try it with 100, 8.75. We can try it with 1,000, 8.64, 10,000, 8.62. Let's try it with this again, 8.63. Try it with 10 to the 5, 8.62, 8.62, 8.62. So it's looking like 10 to the 5 is giving us a pretty good estimate. So we can say on average we expect the length to be a little under, well, we can't have 8.6 elements, but we could round up to 9 and say, okay, we expect about 9 elements. So thank you everyone for watching. I think this is a good place to end the video, and I will see you in the next one.